overall goal was to decipher the genetic code. So in 1961, he got together with Matthaei. And at the time, scientists knew that DNA directs the synthesis of RNA, and that RNA was implicated as a template in protein synthesis. So Nirenberg and Matthaei conducted their experiments in approving this RNA connection. Now, basically, the experiment was just blending E. coli to extract cytoplasm and ribosomes and then put this solution in a test tube. Now, the solution then was going to be 19 amino acids added and 1 radioactive amino acid to track which amino acids are going to be coded. Now, these amino acids, they're going to make proteins, and then the RNA is going to be translated. Nirenberg found that any RNA that's going to be added is going to produce a protein, and also that the ribosomes can create the proteins non-exclusively. So this could possibly lead to how the genetic code was then translated. So Matthaei added the straight codon of uracil, UUU, and found that it then coded for the protein of phenylalanine. Now, this straight codon of UUU is determined as a polyU mRNA or a homopolymer, which was a breakthrough, because then they knew that the polyU mRNA then directed the incorporation of phenylalanine into a protein, but they didn't know exactly how many uracil containing nucleotides were required to create a codon. Was it 2, 3, maybe 4? Well, there's 20 amino acids that they had to accommodate for, so there needed to be enough in the codon length in order to cover all these amino acids. So in order to test this, 3 years later, we have new technology and a new partner. So Nirenberg gets together with Leader, and they're determined to find a codon's length. Now, they have new technology, so now they're allowed for all codons to be made and not just homopolymers. So this experiment was similar, but now they're making synthetic mRNA codons and mixing them with cytoplasm, ribosomes, and amacilyated tRNAs, which are just charged tRNAs, and that same 1 radioactive amino acid. By using a filter, the mixture is poured over, ribosomes are captured at the top, TNAs are not bound by the ribosomes, so they pass through. And then that filter is radioactive, so it's filtering that 1 radioactive amino acid, and if any of the amino acids match, then they're going to be caught on top with that ribosome, and then they're going to be coded. And this is how the genetic code is then cracked. So the conclusion from both of these experiments and overall was that it's obvious that RNA is going to be necessary for protein synthesis, and that the sequence of amino acids of a protein is dictated by